Okay, now we're going to look at end behavior while also reviewing the how many bends and the degree. So if I look at the equation here, it's a degree 1 because the highest power of x is 1. So the degree is 1. That's called linear for review. How many bends? And we want to say how many bends like at most. It has 0 bends. I can tell from the graph, or I can tell by the degree. It's always 1 less than the degree. Same or opposite end behavior. So all these graphs were made in decimals, so they don't have the arrows on the end, but they all polynomials always go on forever in both directions. So end behavior just means what's it doing on the ends. On the left side, is it going up or down? And on the right side, is it going up or down? So for this one, when it's degree 1, it's opposite end behavior. It's going up on the left and down on the right. Let's look at number 2. The degree here is going to be 2. I know that when I multiply this thing out, I'll get x squared. And I don't care about the other stuff. I just know that when I do the x times the x, I'll get an x squared, which makes it a degree 2. So that means it's going to have at most 1 bend. Same or opposite end behavior. So when it's degree 2, it's got the same end behavior. It's up on both sides. Left, it goes up, and on the right side, it goes up. Number 3, again, if I multiply this out, I know that I'll end up with an x to the third. I don't know what the rest of them will be, but I know the biggest one will be the x to the third because the x times the x times the x. So that's degree 3. So because it's degree 3, it's going to have at most 2 bends because it's always 1 less than degree. Let's look at the end behavior. When it's a degree 3, it goes down on the left, up on the right in this case. So again, it's opposite end behavior. The next one is a degree 4. So that means it's going to have at most 3 bends. Oh, I should be naming these. Degree 4 is a quartic for review. A degree 3 is a cubic. A degree 2 is a quadratic. So the quartic has at most 3 bends. We're interested in the end behavior now here. It goes up on the left and up on the right. So it's going to have the same end behavior on both ends. Oops. Ends meaning left side and right side. Here's a degree 5. That's a quintic. By name, it's going to have at most 4 bends. It's got end behavior. On the left side, it's going up. On the right side, it's going down. So it's got opposite end behavior. Number 6 is a degree 6. I don't know the name for this one. I think we just call it a polynomial of degree 6 once we get over 5. How many bends does it have? At most 5. So in this case, it doesn't have the 5. I see 1, 2, 3. So remember, it's at most 5. So 3 is okay. Same or opposite end behavior. So this was an even, a 6 degree, and it's got the down on both sides. So it's the same end behavior on both sides. So for number 7, I'm going to let you guys do that on your own. We can talk about that in class. You can come up with a possible equation for the following graphs. Let's talk about what we notice here with the end behavior. So when the degree, the highest power, is even, we're always going to have the same end behavior. Okay, so end behaviors are the same in this column, and here they're opposite. So notice the end behaviors here. Who knows how many turns there are in the middle, right? But I'm looking at the end behavior. When it's odd, it's going to be the opposite. So let's look back here and notice that. This had a degree 1, which was odd. which means the end behaviors are opposite, up on one side, down on the other. This one, the degree was 2, so that's even. Okay, so the end behavior on both sides is the same. In this case, they're both going up, and so on and so forth. Let's look at another one, degree 6. That's even, so the end behavior is the same. Even though there's a bunch of turns in between, right? All of these have turns in between, that we're really just focusing on the end behavior. So that's what these pictures are saying. Like, look, I could have only one turn in between. I can have multiple turns in between. But if it's an even power, the end behavior is going to be going both up or both down if it's an even power. Now, how do we tell if it's both up or both down? We can tell that by the coefficient, if it's positive or if it's negative. So a positive leading coefficient. So that means the guy that's in front. So here that's like a 1. That's the number in front of the highest power of x. Since that's positive, we know that it's going to be up on both sides because the coefficient is positive and the degree is even. So even degree means they're both the same. Positive coefficient means they're both up. Notice the even degree here means they're both the same, but a negative coefficient means they're both downward. For the odd ones, you notice that if it's odd with a positive coefficient, it's going to be down on the left and up on the right. I just think like the easiest one is when you draw a line, a degree 1, it's got positive slope like y equals 3x. It goes down on the left and up on the right because it has positive slope. If it had negative slope, a line with a negative slope would go this way, and it would be up on the left and down on the right. So that's how I remember it. So we've got, here's an example where the degree is odd. The degree here is 3, so it's odd. The coefficients are negative numbers, so that's why the end behavior is going to be up on the left and down on the right. So let's try to do this. Describe the end behavior of each function. So since the highest power of x is 4, that's even, which means it's going to be the same end behavior on both sides. And because the coefficient is negative, so the degree is even, the coefficient, that's the number in front of the x, is negative. That means it's going to be down on both sides. Let's look at an odd one. Here's an odd one. The degree is odd, so that means degree odd means it will be different on both sides, the end behavior. And then the negative in front means that it'll have, like I think of a line with a negative slope, it'll be up on the left and down on the right. Because I think a line with a negative slope like negative 3x or negative x, that's going to go like that. So even though mine's a higher power, 3, it's still going to follow that same end behavior. It's going to be up on the left and down on the right. The 3 just means in between it might have a couple extra turns that a line doesn't have. So you're going to finish these up on your own and try to see if you can come up with what the end behavior is for 2, 4, 5, and 6.